Hey everyone, in this video I'll show you how to convert an equation like this into standard form, which is what you need to do if you're graphing an ellipse or hyperbola. This equation is an ellipse, but if you're working with hyperbolas, you would do the same process to convert the equation. What we're going to do first is rewrite the equation to group the x terms and the y terms, and then get that constant on the right-hand side. So that gives us 9x squared plus 36x plus 4y squared minus 24y, and then because I want to get this constant on the right, I'll subtract that from both sides. So that gives me all this on the left-hand side and then negative 36 on the right-hand side. My next step, I'm going to rewrite this and do a couple things at the same time. I'm going to factor out any GCF of the x terms, and I'll do the same for the y terms, but I'm also going to leave a space for what I'll add when I complete the square. So that's what this looks like. Factor out that 9, and I get x squared plus 4x, and then I'm going to leave that space because I know I'm going to add something to complete the square. Same thing here, we factor out the GCF of 4, and I rewrite this. Now, on the right-hand side, I know I have a negative 36, but I'm also going to have to add some things over here to balance out what I'm adding over here. And I'm not going to write just plus blank because I need to, in this case, remember that this is really getting multiplied by 9. So I'm going to write plus 9 times blank, and same thing here. For this one, I'll write plus 4 times blank. So what do we add in the blanks? Recall completing the square, we look at this term and we take half of its coefficient, in this case that'd be 2, and we square it, and that's what we add. So 2 squared gives us 4. And then we add that over here. We write it right in the blank right away. And then over here we have half of this coefficient will give us negative 3. We square that, we get 9. And we write that over here as well. So for our next step, we are going to do some simplifying. And recall, since we made these things be perfect squares, we can collapse them down as we write our next step. So I've got my 9, and then all this can be rewritten as x plus 2 quantity squared. And then here, I've got my 4, and I can rewrite all this as y minus 3 quantity squared. Over here, I can just do some simplifying right away because 9 times 4 is 36, and 4 times 9 is also 36. So we've got negative 36 plus another 36. Well, this can cancel with that, leaving us with just 36. So I'm coming up to the last step here. For ellipses and hyperbolas, we need the right-hand side of the equation to equal 1. So we have to divide everything across the equation by whatever will give us 1 over here. In this case, we'll divide by 36. So those cancel out and give us 1 on the right-hand side. And then over here, on the left-hand side, well, we can simplify. 9 goes into itself once, and 9 goes into 36 4 times. So in our numerator, we have x plus 2 quantity squared, and our denominator of that is 4. And here we can do some canceling also. 4 goes into itself once, 4 goes into 36 9 times. So we have y minus 3 quantity squared over 9. And that is our standard form, which will help us easily graph this ellipse. And I will link another video that shows you how to do the graphing of this particular equation.